Let's study about determinant. This is one of the most important chapter of mathematics, and this is in class 12. So this class will be useful to the schooling students of class 12 having a subject mathematics. Today we shall discuss about definition of determinant, extension of determinants, evaluation of determinants, properties of determinants, minors and cofactors of determinants, product of two determinants, summation of determinants, differentiation and integration of determinants, application in solving a system of linear equation, application in coordinate geometry, some special determinants. So without any delay, I am going to start this class. Let's see. So let's see here definition of the determinant. Consider two equation a1x plus b1y equal to 0. This is the equation number 1, and a2x plus b2y equal to 0. This is the equation number 2, and both are a linear equation in two variables, multiplying 1 by b2 and 2 by b1, and subtracting, dividing by x, we get a1 into b2 minus a2 into b1 equal to 0. The result a1 into b2 minus a2 into b1 is represented by uh, a1 b1 a2 b2 enclosed by the vertical line, which is known as determinant. So this is the definition of the determinant of order 2. So it has two row and two column, and a1 into b2 minus a2 into b1 is the expansion of this determinant. The horizontal lines are called rows. So this is the first row and this is the second row. And vertical lines are called columns. So this is the first column and this is the second columns. Now let us consider three homogeneous linear equation where linear equation in three variables which are x, y, z. So a1x plus b1y plus c1z equal to 0. This is the first linear equation having three variables. a2x plus b2y plus c2z equal to 0. This is the second linear equation. And a3x plus b3y plus c3z equal to 0. This is the third linear equation. So now let's see, this is the eliminated by x, y, z from above three equation. We obtain a1 b2 into c3 minus b3 into c2 minus b1 a2 into c3 minus a3 into c2 plus c1 a2 into b3 minus a3 into b2 equal to 0. So let's see here, the LHS of third is represented by, we write down the coefficient of each equation. A1, B1, C1 are the coefficient of the equation number 1. A2, B2, C2 are the coefficient of equation number 2, and A3, B3, C3 are the coefficient of equation number 3 of x, y, z respectively. So hope that there is no problem to understand. It's contain three rows and three columns. It is called a determinant of third order. number of rows and columns clear the order of the determinant. A determinant is a square matrix. So hope that there is no problem. The number of element in second order is 2 by 2 equal to 2 to the power 2 equal to 4, and the number of element in third order is 3 to the power 2 equal to 9. So let's see here, if we have idea about the order of the determinant, then we have no problem. Total number of element in this determinant. So the number of element in a first order will be 1 to the power 2 equal to 1. So here number of element will be 1 when the order of the determinant is 1. Row and columns of a determinant. In a determinant, horizontal lines counting from top, first, second, third, respectively, known as the rows and denoted by R1, R2, R3, and vertical lines counting left to right, first, second, third, respectively, known as the columns. So vertical lines are the columns and the horizontal lines are the rows. So number of rows generally counted from top to bottom, and number of columns generally counted from left to right, and denoted by C1, C2, C3. Hope that there is no problem to understand up to this step. So let's see the shape and constituent of a determinant. Shape of every determinant is a square. If a determinant of n order, it means that n by n. So it has n rows and n columns. It contains n rows and n columns. Example for number of constituents in the determinant is n square. So number of constituent just equal to the number of element equal to order square, so n square. Sign system for expansion of determinant. Sign system for order 2, 3, order 4 are given by. This is the order 2. It has 2 rows and 2 columns, plus, minus, and minus, plus. Third order, it is started from plus, plus, minus, plus. After that, minus, plus, minus, and plus, minus, plus. Fourth order, it means that plus, minus, plus, minus. Alternatively, we start to plus and write minus, plus, minus. So this is the plus, then I start from minus, plus, minus, plus, and so on. Of that, there is no problem. The number uh, sign system for expansion of determinant. Let's continue the class or develop the class. So unlike a matrix, determinant is not just a table of numerical data, but quite differently a shorthand way of writing algebraic expression whose value can be computed when the values of terms or elements are known. So let's see here, the four numbers A1, B1, A2, B2 are arranged. A1, B1, A2, B2 is a determinant of second order because it has two rows and two columns. These numbers are called elements of the determinant. The value of the determinant is defined A1 B1 A2 B2 equal to A1 into B2 minus A2 into B1. The expanded form of determinant has factorial 2 terms. The 9 numbers A, R, B, R, C, R are equal to 1, 2, 3 arranged as A1, B1, C1, A2, B2, C2, A3, B3, C3 is a determinant of third order. Take any row or column, the value of determinant is the sum of products of the elements of the row or column, and the corresponding determinant obtained by omitting the row and column of the element with a proper sign given by the rule -1 to the power ij, where ij are the number of rows and number of columns respectively of the element of the row or the column chosen. So A1 B1 C1, A2 B2 C2, A3 B3 C3. When we consider A1, then we write down, we cancelled out this one, we cancelled out this one, then we get B2 C2 B3 C3. After that, when we consider about P1, so we cancelled out this one and we write down A2 C2 and A3 C3. So this is similarly when we eliminate this one, then we cancelled out these two. Then A2 B2, this is the A2 B2 and A3 B3. The diagonal through the left hand top corner which contains element A1, B1 and C3 called. So A1, B1, C3 called the leading diagonal or principal diagonal, and the turn are called the leading terms. The expanded from the determinant has factorial 3 terms. Shortcut method or a state Sarah's diagram method. So to find the value of the third order determinant, following method is also useful. Taking product of RHS diagonal elements positive and the LHS diagonal elements negative, and adding them, we get the value of determinant as A1 B1 C3, B1 C2 A2, C1 A2 B3, C1 B2 A3, A1 C2 B3 and B1 A2 C3. This method does not work for determinant of order greater than 3. Let's see evaluation of determinant. So if A is a square matrix of order 2, then its determinant can be easily found, but to evaluate determinants of square matrices of higher order, we should always try to introduce zeros at maximum number of places in a particular row or column. By using the properties, and then we should expand the determinant along that row or column. So you are independent to select one row or column. We shall be using following notion to evaluate a determinant. Ri to denote ith row, Ri Rj to denote the interchange of ith and jth row, R1 Ri lambda Rj to denote the addition of lambda times of the element jth row to the corresponding ith row. R1 lambda to denote the multiplication of all elements of ith row by lambda. Similar notion are used to denote column operation if R is replaced by C. Properties of determinant. First property, the value of determinant remains unchanged if the row and column are interchanged. So the value of the determinant are the same. If we if the rows and columns are interchanged. So A1, B1, C1 will be first column A1, B1, C1 and so on. Therefore, D equal to D and D dash are transpose of each other. Since the determinant remains unchanged when rows and columns are interchanged, it is obvious that any theorem which is true for rows must also be true for columns. Second property, if two rows or columns of a determinant be interchanged, the determinant is unaltered in numerical value but change in sign only. So let's see here. This is the determinant A1, B1, C1, A2, B2, C2, A3, B3, C3. Let's see here. We interchange first and second row. Instead of first row, I have written the second row A2, B2, C2, and instead of second row, I have written the first row A1, B1, C1. Then we get determinant of D dash equal to minus determinant of D. If a determinant has two rows or two columns identical, then its value is 0. Let D equal to A1, B1, C1 and A1, B1, C1. So this matrix or determinant has R1 and R2 are equal. Therefore, the value of the determinant will be 0. Let's see the fourth property. If all the determinant of any row or column be multiplied by the same number, then the value of determinant is multiplied by that number. So if all the determinant of any row or column be multiplied by the same number, then the value of determinant is multiplied by that number. So let's see here A1, B1, C1, A2, B2, C2, A3, B3, C3. This is the value of first determinant and the value of second determinant whose first term or each term of the first row multiplied by k. Therefore, complement of D equal to KD. Of that there is no problem to understand up to this step. So it is necessary to read the or remember the properties related to the determinant. Let's see the fifth property. If each element of any row or column can be expressed as a sum of two terms, then the value, then the determinant can be expressed as the sum of the determinants. For this, let's see the one example. A1 plus x, b1 plus y, c1 plus z equal to here will be a1, b1, c1 and we write down r2 and r3 here. Similarly, now we write down x, y, z and there is no change in the first row, sorry in the second row and third row. Let's see the properties of 6. The value of a determinant is not altered by adding to the element of any row or column the same multiples of the corresponding element of any other row or column. So let's see here determinant equal to a1 b1 c1 a2 b2 c2 a3 b3 c3 and d dash equal to a1 plus m a2 and b1 plus m b2 and c1 plus c m2 a2 b2 c2 and here will be a3 minus n a1 b3 minus n b1 and c3 equal to n c1. It should be noted that while applying property 6, at least one row or column must remain unchanged. Let's see the seventh property. This is the seventh property. If all elements below leading diagonal or above leading diagonal or except leading diagonal elements are 0, then the value of the determinant equal to the multiplied of all leading diagonal elements. Of that there is no problem to understand the property 7. So this is the first determinant a1 b1 c1 or 0 b2 c2 or 0 c3 equal to here will be a1 and we write first column in the first row and second column, this is the second row and third column, so 0 c3, this is the third column. So how that there is no problem to understand this one. I am going to take a break of 5 minutes. After that I shall continue other material of tuition. Till then, thanks to all of you. Let's see the property 8. If a determinant D becomes 0 on putting x equal to a, then we say that x minus a is a factor of determinant. So let's see the determinant equal to x5 2, x2 9 4, x3 9 8. So this is the determinant of, and at x equal to 2 determinant equal to 0 because c1 c2 are identical, and at x equal to 2. Let's see the not, hence x minus 2 is a factor of d. It should be noted that while applying corresponding operation on determinants, then at least one row or column must remain unchanged. Maximum number of operating operations or order of determinant equal to minus 1. So it should be noted that if the row or column which is changed by multiplying non-zero number, when the determinant will be divided by that number. So n not equal to 3k and 1 omega square. The cube root of unity then we shall discuss last other in